Hello everybody, this is the second video for section 3.5, Algebra 2 Trig. This is the example. We're talking about linear programming, which is systems of inequalities and an extra equation called an objective function. You are trying to either maximize it or minimize it or get a certain goal out of that objective function. So the first step is to write a system of inequalities that represents the constraints of the function or the whole situation. So hit pause, take a second, try to read through this, come up with your own system of inequalities from this. All right, hopefully you got it. So small company produces knitted Afghans, which are blankets or shawls. I had to look it up in the dictionary. And sweaters, so Afghans and sweaters, and sells them through a chain of specialty stores. The company is to supply the stores with a total of no more than 100 Afghans and sweaters. So we got two things. I'm going to call these X and Y. We got Afghans and sweaters. It says a total of no more than 100 Afghans and sweaters per day. All right, so no more than those. So it's going to be less than or equal to 100. You got a certain number of Afghans, you got a certain number of sweaters, total of no more than 100. So that's one equation, or one constraint. The stores guarantee that they will sell at least 10 and no more than 60 Afghans. So Afghans were X. It was at least 10, no more than 60. So greater than or equal to 10, no more than 60, so less than or equal to 60. And again, that was the Afghans, that was X. And it also says, and at least 20 sweaters per day. Sweaters were the Y value, so at least, greater than or equal to 20. Now it says the company makes a profit of $10 on each Afghan and a profit of $12 on each sweater. That's not really a constraint. That's going to come towards our objective function. So these three equations are what we're looking at. Now, again, you always have to make sense of the situation. We got two more equations. I just ran out of space. I'm going to write them over here. You're not going to be making negative Afghans. You're not going to be making negative sweaters. Sorry about the weird-looking inequalities. The board jumps right there. So these five inequalities, this is your system of inequalities. It's the constraints on the problem. All right, so part B says to graph the feasible region. Find the coordinates of the vertices of the feasible region. So let's go to the next page. Here's that system all nicely typed out, looking good. I'm going to make each of these tick marks go by tens. So way out here is 100. Same thing on the y-axis. So that first equation, it's basically in standard form, so I'm going to go with the intercepts. It's going to cross the x-axis at 100, the y-axis at 100. It is an or equal to, so solid line. Now, if we test the point 0, 0, that makes that a true statement, so we are going to be shading below the line. I'm going to switch colors here. For the next one, the second equation, x value is greater than or equal to 10, but less than or equal to 60. So solid line at 10, solid line at 60. See 10, 20, 30, 40, 50, here's 60. Solid line. We have x values greater than 10, so we're shading this way. X values less than 60, so we're shading in between there. All right, switch colors one more time. We got y values greater than or equal to 20. And it's or equal to, so solid line at 20. Y values greater than that, so I'm going to be shading above. And we have the restraints of can't have negative values. And those are our axes, and that really doesn't come into play with the feasible region. All right, so above the blue line, below the red line, in between the green lines, that is all of this space. Okay, so all of that space where that little guy is. So that is the feasible region. Now, we also need to find the vertices of this feasible region. This is actually kind of easy for this problem. What you may have to do with other problems is solve the system, figure out where those two lines are intersecting. So you'd have to do substitution or elimination to solve that system. They're not always going to be nice and convenient like this example is. But we have this vertical line here at 10. We got this horizontal line at 20. That means this point is at 10, 20. Same idea over here. This point is at an x value of 60. It's on that horizontal line of a y value of 20. For this one, the intersection of this line, we got an x value of 60. And this is on that red line. That was this first equation. So if x is 60, what would you add to 60 to get to 100? 40. For this feasible point way up top here, we are at an x value of 10. Same idea. It's the intersection with the red line. So if x is 10, y has to be 90. And there is all four vertices for the feasible region. Okay, that's part B, taken care of. Part C, write an objective function for the company's total profit, P, from the sales of the Afghans and the sweaters. All right, that's this part down here. The company makes a profit of $10 for each Afghan. So the profit would be 10x plus, and a profit of $12 for each sweater. So 12 times y. This is our objective function. Now, part D. What is the number of Afghans and sweaters that need to be sold to maximize the profit? All right, I'm going to take this equation, move back to the other page here. So our objective function, the profit equals 10x plus 12y. And what we're going to do is test each of these points. So for the first point, 10, 20, I'm just going to plug it in and get my profit value. So 10x, that's going to be 100 plus 240, that's 340. Okay? For the next point, it doesn't matter the order you go in, 60, 20, that is going to equal 600 plus 240, which is 840. All right, so you can already see that this is better than the first point. Let's go to the next one, 60, 40. And when you're doing this, I highly recommend just picking a point and then just going around your feasible region so you make sure you cover all of the points. All right, so plug it in 60 for x. That's going to be 600 plus with 40, that's going to be 4,800. That's 1,080. And the last point, 1090. I should have been putting equal signs here. These should just be arrows. That's okay. Plugging in 10, we get 100 plus. Plugging in 90. That is going to be, 9 times 12 is 108, add a 0, 1080. So that's 1180. That's the biggest number. We wanted to maximize the profit. So our solution to this whole situation is that point. That is the point that maximizes the profit with these restraints. Okay? This is the idea of these linear programs. You're going to come up with the inequalities, if they're not already given to you, the system of inequalities. You're going to graph it. You're going to find those vertices of the feasible region. And then with that objective function, you're going to test those vertices and figure out which one satisfies the problem, whether you're maximizing things, whether you're minimizing things, whatever it is. All right? It's just one example today because it took 9 minutes to go through this. So that is it. I will see you in class Friday. Have a good night.